So now I want to multiply equation 2 by 4. So equation 2 was 5x minus 2y is equal to 8. So we multiply each side by 4 in this case, and we're going to end up with 20x minus 8y is equal to 32. And this is what we're going to say is equation 4. So now we have our new set of system of equations, which is going to be negative 20x plus negative 15y is equal to negative 45. And that is equation 3, and 20x minus 8y is equal to 32. Oop, not adding them quite yet. And this is our equation 4. So this is our new system of equations. And now for step 3, we want to add equations 3 and 4. And we want to add them vertically, so we have negative 2x plus negative 15y is equal to negative 45. And then we are adding 20x minus 8y is equal to 32. So negative 20x plus 20x is going to give us 0x. Negative 15y minus 8y is going to give us negative 23y. And negative 45 plus 32 is going to give us negative 13. So, step 4. And remember, these are part 2s as well. So step 4, part 2. We're left, and we just want to simplify for y. So we have a negative 23y is equal to negative 13, where we divide each side by negative 23. And we get that y is equal to 13 divided by 23. So we found a value for x, and we found our value of y. It's important to note that we don't need a step 5, since in this case, steps 2 through 4, part 2s, replaced step 5. Since step 5 was just finding our other variable, or the value of our other variable, since we did steps 2 through 4 again, since it would be difficult to go ahead and plug in x into our equations to solve for y, we'll just say that steps 2 through 4, part 2, replace step 5. So now we're just on to our step 6, where step 6 tells us that we want to replace x and y with these new values, but since these values of x and y are messy and difficult, we can check if our solution, which is 42 divided by 23, let's go ahead and write this on another line. If 42 over 23 and 13 over 23 is a solution by graphing. And we're going to check with a graphing calculator. So we're going to go on over to Desmos and see by using Desmos if it's going to be a solution. So using a graphing calculator, this is one of the occasions that if you use a graphing calculator, some sort of online graphing system, it is a little easier to check a solution, not find an exact solution to begin with. So let's head on over to Desmos. So in Desmos here, we have our two equations graphed on our line. So our first equation being 4x plus 3y is equal to 9, represented by the red line. And our second equation, 5x minus 2y equal to 8, represented by our blue line. And we see that they intersect at a point. We know that the solution is this point that they intersect. So if we hover over this point, this tells us 1.826 and 0.565. Now, if we calculate 42 divided by 23 and 13 divided by 23 by, or if we divide these numbers and turn them into decimals, we will end up getting these values, which we can go ahead and we can just plug these values in anyway. So we said that x was 42 divided by 23. So we see a line, we see that this calculates as 1.826, and we see this green line going through our point. And then we said that y was equal to 13 divided by 23, which is calculated as a 0.565. And we see this purple line going through our solution point here as well. So in order to just check to make sure that an answer is correct, you can also always graph it this way. So when you have kind of these more difficult and messier solutions, you can check this way as well. And this just makes it a little bit easier, so you're not actually plugging in these fractions back into your equations and having to do all those calculations. So let's head on over back to our notes. So by using Desmos, and Desmos is the name of an online graphing calculator. So by using Desmos, we confirmed that our point, 42 divided by 23 and 13 divided by 23 is our solution. So our final answer here, which is our solution set, is just our ordered pair in curly braces. So 42 over 23 and 13 over 23 in our curly braces. So when using your elimination method, you can always use your elimination method twice if you end up with some value that would be difficult to plug back into your original equations. And then lastly, objective 4, we want to solve special systems by elimination. So example 3, we want to solve each system just as we did before. So starting with part A, step 1, already in standard form, so nothing to do there. We'll move part B over a little bit, give us a little bit more room for part A. Step 2, we want to think about multiplying one of our values in order to get opposites. So in the case of equation 1, we have 2x plus 4y is equal to 5. In equation 2, we have x plus 2y is equal to -9. So our coefficients for x are 1 and 2, and our coefficients for y are 2 and 4. So let's multiply equation 2 by -2. So we multiply equation 2 by -2. And this gives us x plus 2y times -2 is equal to -9 times -2. So this is going to give us -2x plus a -4y is equal to +18. We're going to call this equation 3. And now in step 3, we're going to add equations 1 and 3. So our first equation was 2x plus 4y is equal to 5. This is our equation 1, and equation 3 is negative 2x plus negative 4y is equal to 18. And we're adding these equations. So 2x plus negative 2x is going to give us a 0x. 4y plus negative 4y is going to give us a 0y. And 5 plus 18 is going to be 23. So 0x plus 0y is going to give us 0 equal to 23, which is not a true statement. So we see that we didn't find a value for x or y, but we did establish that 0 is not equal to 23. So since we're actually not solving for any variables here, it doesn't matter any value we plug in for x or y, there's going to be no solution. So this statement is false. So since the statement is false, this means we have no solution and our system is inconsistent. And remember, this means that we have parallel lines. So since we've established that our statement is false, we would just stop at step 3. We say your statement is false, there's no solution, our system is inconsistent, which means we have parallel lines. So this just tells us that our final answer, or our solution set, is just the empty set. Since there is no solution, we write out the empty set. Now, moving on to part B. We want to do all the same steps as before. So, part B, step 1, remember that we just want to make sure it's in standard form, which we have 3x minus y is equal to 4, and negative 9x plus 3y is equal to negative 12. So, already in standard form. Step 2, we want to multiply one of our equations by a value that would give us opposite coefficients of one of our variables. So we consider our coefficients for x are 3 and negative 9, and our coefficients for y are negative 1 and positive 3. So let's go ahead and multiply equation 1 by 3. So multiply equation 1 by 3. So equation 1 is 3x minus y is equal to 4. So now we're multiplying these by 3. And we'll get 9x minus 3y is equal to 12. And we'll call this now equation 3. So step 2, we want to add equations 2 and 3. Equation 2 we said was negative 9x plus 3y is equal to negative 12. So equation 2, and equation 3 is 9x minus 3y is equal to 12. And we're adding these equations together. Negative 9x plus 9x is going to be 0x. 3y plus negative 3y is going to be 0y. And negative 12 plus 12 is equal to 0. Now 0x plus 0y is just equal to 0. So what we end up getting is that 0 is equal to 0, which is a true statement. But we didn't solve for a variable, which means that any value we plug in to X or Y would still make these statements true. This was step 3, not step 2. Step 3. So we can say that this statement is true. So since the statement is true, this means our system has infinitely many solutions and our equations are dependent. So if our system has infinitely many solutions and our equations are dependent, this means that our equations are the same. They're going to be on the same line. So we have to write our final answer just as we had before in our last section. We write our final answer or our solution set in set builder notation, which we state that any point X or Y, any point X or Y can be plugged into any equation. For example, we can list our equation 3x minus y is equal to 4, and any answer would be correct. Once again, you could plug in any equation into our set builder notation. I just plugged in equation 1, but you could plug in equation 2. It just has to be one of our original equations. And that would conclude our section on solving systems of linear equations by elimination. So I'll see you all in the next section.